EMT that was based, and I think it might still be based, in Berlin, or at least our colleagues who were working with us were based here. So it's kind of almost coming back to the roots of some of our partners where this originated. Did you want to give me a hand with the slides, and then I can just say a few words? So as I say, this was an evolution for me. So my background is in design, actually, design of systems. But last 10 years or 12 years, I've been involved with the European projects, originally invited by the European Commission to join projects, and got involved from the perspective originally of music information retrieval from a domain that was one of the first in the world that had to migrate entirely to the digital and was entirely data reliant, and therefore there was a huge amount to learn from that domain about the implications of data on new user behaviors, on new business models, on new kinds of applications that can support an entire system. And it is quite striking how many of those patterns that were identified in our early research with that domain have actually been shown in other domains since, even in domains that now, of course, have digital twins that are connected to tangibles. So some very, very interesting patterns on that. Other than that, for the last 10 years, I have been advising to the EU about innovation. So I was involved in the original shaping of the concept of innovation ecosystems back in the day when, at the times of Juncker, and more recently, I have been involved in the various fora together with industry, but more recently, as you might be aware, I've been part of President von der Leyen's high-level roundtable for the new European Bauhaus initiative, which creates new methodologies for the implementation of the Green Deal. So that's just briefly about me. Now about a bit about a background of how this industry commons idea came up. We can do it from here. That's fine. No worries. I can just run it from here. That's shown on here. Oh, you don't see it on the online. Okay. Do you want me to say next slide?
No, you can use the.
I can use that. Okay. Right. You're on slide. Yes, like that. Good. You can see it. Great. So, of course, the kinds of bottlenecks that we identified in 2015 when we were running these pilots were things that are now well known and were already becoming known at the time, perhaps not by all domains, but it was very clear in our experimentation that there was never enough data. We had trouble with interoperability. At that time, we were solving it, of course, with APIs. So we were bringing all these domains together in our pilots, and the only way that we could connect them is by writing APIs. We identified very early on that there was an issue with proprietary IP. We had industry come to us. We had people like Philips, for instance, come to us. And there was issues, of course, with releasing data into the system. This became a well-known bottleneck. And of course, particularly when it came to data that was assisted by AI, so AI-driven systems, for example, or AI-assisted neural networks and things like that, use cases were proving to be really unpredictable in terms of what kind of results we were getting. So our answer to this was to develop the idea of industry commons to gather data into one place, to create a pool of data that we could use. As I say, we solved a technology transfer with APIs at the time. Of course, what has happened since is the OntoCommons ecosystem, which is a far more stable and more reliable top-level reference model for this type of challenge. we started to build IP stacks of different types of IP. So we acknowledged that people had ownership of IP, and we started to track how this IP is built together with other domains' IPs, and started to build that. This is now something that we are also pursuing in a new project called Ready, or fairly new, sort of almost a year now. And when it comes to unpredictable use cases, we were able to test use cases, and we identified that some of the best breakthroughs were coming in the gaps between the different domains. And this was really encouraging, because then we developed a system for market adoption readiness that was able to manage early adoption of these new use cases. And therefore, it wasn't just relying on technology readiness, it was relying on several other parameters, such as how much data we were able to collect from early adopters, and what was the level of risk of an early application. So these were the sort of concepts that drove the initial proposal of OntoCommons, which at that time I was part of the founding of the Alliance of Internet of Things Innovation for the European Commission, and proposed that to the innovation ecosystems in the AOTI. Now, how does this differ from traditional models of the commons? And I think this is quite an important point to remember. There is this real confusion out there in terms of the idea of a common as it is being used in the Anglo-Saxon word, which is basically systems where land ownership was the dominant power structure, and the common resource was always finite. It was delimited by the big power structures, and it created an economy of scarcity. So incentivized particularly negative behaviors. Now, this has been used hugely in economics, and it's a very simplistic interpretation of people's interaction in a common system, because, of course, it is subject to these particular conditions. What's particularly important to remember about those kinds of conditions is the actors are stripped of agency. So if you actually look at the Nobel laureate's work, Elinor Ostrom's work on the governance of the commons, she refers to some of these famous paradigms from economics, such as the tragedies of the commons, for example, where an actor will always try and gain as much as possible out of a limited resource. Or, for instance, Prisoner's Dilemmas, which you're probably familiar with. She says the observer always wishes to evoke images of helpless individuals caught in an inexorable process of destroying their own resources. So there's this helplessness that is embedded in this concept. And of course, in the industry commons, one of the most important things is agency of the involved actors. So that means in terms of data sovereignty, in terms of decision-making processes, in terms of governance that's distributed, all of this gives people agency, and that creates a completely different dynamic. So this is important to distinguish from some of those systems that have been presented. And the other thing that's really important to remember that is not present in some of these models that have been critiqued by Ostrom, and that is that, and that's my observation really on this, is that in these models, actors are completely stripped of knowledge, domain specialization, or any kind of unique value that they can bring to the system. So whether this be like a novel idea or whether they bring an additional resource. Because of course, when individual contributors bring the knowledge that's needed by the group, then of course cooperation becomes a necessity. So some of these behaviors that are described in some of those models do not apply anymore. And this is essential because, of course, that's why cattle grazing is not a particularly great metaphor for spaces of knowledge exchange. And we can't take some of these examples at face value. So bringing knowledge together from various domains is essential for common incentives and motivations for cooperation. And therefore, industry commons requires support for the valorization of knowledge exchange. So interoperability, and in this case, OntoCommons as a key pillar of interoperability for the industry commons, is a key enabling dimension, but there are several others that are part of the enabling systems of the industry commons, because data, of course, and interoperability can't exist in isolation. So One is the systems of agreements. We mentioned before proprietary IP. This is extremely important. So it's not only the matter of embedding regulation and agile ways to create peer-to-peer contracts, but also tracking intellectual property and making sure that people can make informed decisions based on this. Systems of resilience, of course, we need to monitor environmental sustainability to create resilience. And we need to, if you're familiar with the donut economy model, for example, by Kate Raworth, you will know that there are ceilings that we need to hit, particularly when it comes to materials and exploitation of materials. Systems of responsibility, of course, we need to embed, for example, responsible AI, corporate social responsibility, and all of this sits on systems of beliefs, i.e. our societal values. And we can embed, for example, our ideas on inclusion into our systems. For example, we can highlight data bias in a system that we propose, for example, to EOSC, which has been really well received. We proposed to match fair with just data annotation, a responsible researcher who aims to be judicious, unbiased, safe, and transparent. Knowledge about the data set can actually be even more valuable than the data itself. And if we build knowledge pools about our data sets, from researcher to researcher, we can have a far more informed, we can make far more informed decisions about how to use that data. Now, what's really unique about this stack is that then it enables us to build breakthrough innovation, because of course, all of these are cross-cutting across domains. Now, if we are tracking and tracing what's happening in the system, we can now start to combine intelligence from different domains, knowledge from different domains we can model current and emerging market possibilities when we combine these. And for the very first time ever, breakthrough innovation is trackable in the system. Now, for the large players, this is a huge win-win situation, because this is a huge incentive for them to release their data into the pool. This is what happened to us with Fraunhofer IDMT. At the beginning, their licenses were very restrictive for this type of activity, whereas other partners in the project had MIT licenses on their data. By sort of 2/3 away in the project, the other partners were achieving fantastic results that we were modeling, we were testing new kinds of use cases that were incredibly informative, and they were running off writing papers. And then Fraunhofer IDMT actually had a word with their lawyers and said, can we relax our licenses, because we are not getting the same kind of knowledge back from the system, from these tests. So we actually ended up doing something that's inconceivable, which is to get Fraunhofer to release their licenses, release it under MIT licenses, and actually allow the innovation community to prototype with them, and then be better informed. So this is one example of where this influences behaviors of large players. Going back, there we go. So this builds on the Weikart, Panetto, and Molina chart, which was looking at the qualities or properties of systems versus a single system. And what we've done is we've developed this further to what do those properties mean in a cross-domain ecosystem. So autonomy, for example, in a system of systems, each constituent part has its own autonomy, but there is a supra purpose for the participation of each component in the system. So they are motivated by the supra purpose. The autonomy then in the cross-domain ecosystem, in the way that it's envisaged in the industry commons, has a temporal dimension. There is an increase in dynamic, so the autonomy allows for increase in dynamic states, as in, for instance, cognitive twins. And that gives us far greater possibility for a modular and adaptable system. Belonging, again, each constituent part belongs to a different actor in a systems of systems. Here it is decentralized for a very good reason, for security. We want every actor, every owner, every proprietary owner owner of proprietary data to store its own data. So we want to be decentralized because we want control over the storage of the individual bits of data. But the data is closely monitored and tracked across the whole ecosystem. So the competitiveness between these different actors is balanced by the supra-purpose, because of course our aim is to benefit from each other's domain knowledge. So this is encoded in the social dimensions. And connectivity is not anymore the sort of mesh network that you get in IoT, which is just nodes and synapses in one dimension. In an ecosystem like this, connectivity we consider to be all-pervasive, so basically we operate in several dimensions, creating value ecosystems across different dimensions. Diversity of capabilities is in the systems of systems something that is sometimes controlled. Here is actually key to enabling innovation breakthroughs, as explained earlier. And of course, you want different modules in the ecosystem to be open to the possibility of being matched with diverse other modules, so that they can be modeled and coupled on the fly. So this is where we get breakthroughs. And emergence where, for example, in systems emergence is enabled. Here it is actually completely monitored and trackable through the ecosystem, which is unprecedented, and therefore the detection of breakthrough innovation. For example, any new data set that's generated from modeling new use case scenarios can be notified to the proprietor, and therefore it leads to informed decision making and good allocation of investment and resources. And so how does this link to the, is it down up here? Let's take this away. All right. So why is materials and manufacturing commons important for the industry commons? So if we want to model any Green Deal use cases, and this is across domains, there should be materials and product data available so they can be modeled together for, and they can be actually modeled together with environmental and framework conditions, so we can make the right decisions. It is essential for example, procurement of most suitable materials products and for life cycle management, including, of course, material and product passports. Data standardization in this case, of course, is extremely important, and a top-level metadata standardization would be very recommended for to make a materials manufacturing commons fair. The materials manufacturing commons can support the industry commons decision-making processes based on supplying data about best performing, most resilient, or allowing the industry commons modeling of the best performing, most resilient, most sustainable materials. And therefore, it can also provide direct routes to the industrial supplier, and that's supplying the best performing. And it is also an enabler for the materials and manufacturing commons to interoperate with other domains. For example, it can be joined with legal commons for regulation, or with environmental commons for public monitoring of environmental conditions of industrial applications. So industry commons can work very closely in synergy with materials and manufacturing commons. I will let my colleagues elaborate more about the materials and manufacturing commons. I'm sure we'll hear a lot more about it today. So that's all from me from now. Thank you.
Thank you very much, Michela. So please keep your questions for the end of this